Hello, everyone. Hopefully, you have a great weekend. And what we are going to do today, we are moving towards the join in Spark SQL. What we have done so far, we discussed the join and subqueries in the SQL Server 2019 and Azure SQL. But what we're gonna do, because if you remember, I told in my last video, with SQL it is limited to the structured data set and obviously limited with space. Like you have to expand the disk if you are running out of space, and over the time the database files, once they grow to larger size, you have to optimize the table as well to improve the performance. And obviously at some stage the server drives are going to be reached to their limits if you have on-premises data center. With Azure SQL or with Azure or AWS or Google Cloud, it's a very different story. However, if we want to, go to a setup where we have unlimited storage space, especially on the file system, we place our file there and then we curate, it will really give us more flexibility and an option to query our data and then transform it and then prepare it for further analysis, which opens the door towards the big data analytics, which is more like the key topic of this course, right? And you can see we are slowly moving towards that direction. And trust me that in the day-to-day data engineering work, most of the companies are expecting you to be proficient in extracting, preparing these data so that data can be used by the rest of the business or the data analysts who are working into different area. And even the data scientists, theoretically tell you the truth, the data scientists should extract the data from the data platform, which is obviously prepared by the data engineering team, and then it will create a proper framework of the data team, so everyone is on board, and anything that is causing a trouble, it is evident in front of everyone. Like it's not like in the darkness, like one team know, the other team have no idea because they are working in isolation. So once that pattern has been established, you can literally see a very good improvement in your data assets from the quality perspective, and obviously the correctness and availability perspective. So what we're gonna do today, we're gonna discuss the joins on the Spark SQL. It's quite exciting because the data is sitting in the CSV file on our Databricks cluster. We're gonna read it and then we're gonna go through and we're gonna actually run the join statements. We're gonna go through the same join. We're gonna first run the inner join. We're gonna run the left outer join. We're gonna run the right outer join, and then we end up session with the full outer join. So without wasting any time, let's jump into the demo environment. We'll see how the join condition work in Spark SQL. So let me share my virtual machine. You can see I've already prepared the notebook, and like I mentioned, we will very soon we're gonna see the PySpark, and PySpark is more like the library that or the wrapper that has been actually built in Python, because like I mentioned, most of the people, they are not very comfortable with the syntax of Spark because it is inherited from Scala, and sometimes the writing the internal functions, especially once we do the nesting, it's quite difficult in writing in Scala. But obviously once you know the Scala, it's going to actually give you more power because you are working with a language which is used to develop Spark, right? But if you are not familiar with Spark and you don't not invest your time, a good news is if you know Python, and like I mentioned, Python is great. Like Python is one of the most flexible language you're gonna ever find in this planet so far, right? It doesn't restrict you with any patterns or the syntax is very flexible in terms of learning, and purely it's a data language. There are additional use cases now that obviously the new frameworks have been developed where you can build the web apps, you can build the mobile apps using Python, and many other cases now, especially for machine learning libraries has been built. But Python itself is a pure data related language. That's the beauty of the Python. So obviously that language has been used to build the wrapper on Spark. So you can use Python to interact with the Spark, and underneath the distributed paradigm is going to be handled by the Spark engine. And obviously because we are working in the Databricks, so it's going to be handled by the Databricks on your behalf. So you don't need to worry about the you don't need to worry about the internals of the Spark, because all you need to just run the command on Python, and the rest will be take care by the Databricks cluster. So in the first cell, we are just calling some of the libraries of the PySpark. And if you don't understand PySpark, don't worry. We're gonna have a separate tutorial to understand the PySpark completely. If you have any interest in learning Python or PySpark, that will definitely boost your skill set in the data engineering space. But right now, just consider it. We are at this stage in the first cell. We are retrieving some of the libraries. We are calling them, so we can use the function that have been present into those libraries. And then obviously, if you remember in my last video, especially where I have actually where I have discussed the file system, if you remember, we have the folders on our cluster operating system where we are keeping our files. Last time I actually show you how I have actually moved 80 JSON file which has some sensor data from the root folder to one of the folder, right? Today what we're gonna do, we're gonna use another folder called human resource. That folder is also present on the Databricks cluster operating system, because cluster only have one node. We are using the free cluster. So what we are going to do, we are going to place the files on the operating system or on the file system of the cluster. So let me show you. I have already loaded the file in the folder. If you don't understand how to interact with the operating system command, please watch my previous lecture. I'm going to actually put the description in this video, and if you want just for a refresher, you can refer back to that video. So you can see it has all the files. It has the department.csv, it has the employee department history, it has employees, it has persons, and it has shifts. So these are the 5 tables. I have actually just put a scenario that we have our data in this file, and these are more like a table, right? So if I actually tell you the truth, if I actually show you the structure of these table, the data that I have exported, let me quickly show you the data. And that's where the power of using multiple tool really helps. So if I want to just show you the employee data, let me just run it. And you can see that that's the same data which we're going to actually use. So with I think it's Azure Data Studio. Azure has so many now studios, I have to remember all of them. Azure Data Studio, it gives you the capabilities to write all sort of queries, and the interface of this tool is very similar to real code. And real code, you know, is a really powerful now IDE for developing all sort of application. By the way, once we start working on the shell scripting, because that we need to know as part of our data engineering or data science career, tell you the truth, your investment is going to actually return you a lot of advantage if you understand the the scripting language. Bash is a common one. I would prefer Bash. If you can learn Bash, that would be great. Not compulsory, but PowerShell is more like restricts you only towards the Azure, right? So that's why I would prefer Bash. Now, the advantage of using Azure Data Studio instead of SQL Server Management Studio, Azure Data Studio is a multi-platform application. Like it's not a Windows based. It's a multi-platform tool that you can install on Linux or you can install on Mac, and you can access the database server, which was not even a concept like a decade ago, where everything is compliant to Windows operating system. Now you can see you can use the same tool and same resources on any platform. And if you remember, in one of video I've actually shown you, I was using exactly the same database but on the Linux environment. I have Ubuntu on my virtual machine and I was using it. So think how things are improving, and we have more and more opportunities and options are available to use the technologies which were not available to us due to the different barriers in the past. Now coming back, so you can see the data there, and these are the table I have already extracted. And by the way, if you are familiar with Azure Data Studio, once you run any query and you get the output, there's a button that will help you to extract the output into different formats. So you can see you can extract this output into CSV, you can extract it into Excel, you can extract it into JSON, and you can extract it into XML. So there are multiple formats, and if you want, you can actually use any of these format to convert your output, and then you can load it into your Databricks cluster. And by the way, that's a manual step, but we will very soon see how we can automate that work. That if we can read the outcome and we can throw it onto one of the cloud storage and read it from there, because that will really cover the whole scenario. So now coming back to our Databricks environment. So you can see I have all these files available. So I've just defined a variable, and you can see I don't need to define any syntax command. I can do just I put the variable name and then I can define the value. And that's why I'm saying Python is really powerful in a way that based on your value, it automatically defines the type of the variable, which is very good. Like with C++, you have to be very careful with the syntax and with the caps of the variable. So the rest of the variables are same. Like you can see file type, and we have infer schema. We put it false because we are not letting Databricks to automatically assign data types. Our first row has the header, so we just put this variable as true, because all these variables we are going to pass, and obviously because it's a delimiter file, CSV file, so we are going to pass the delimiter, which is comma in the CSV case. Let me run it. We are good. Now we are going to load our first table, which is sitting in the CSV. And if you remember, I shared a video on introducing the data model of this video, and I discussed that data model in this video. Please refer back to that video if you don't understand these table. I have explained them, and then come back and watch this video. You're going to actually understand what we are doing in here. So we have a person table that contains personal information. Let me run that table. So the command is same like which we are using in last couple of videos, especially in Spark. We are using read command, and we are providing all these options which are part of the syntax, and then the last command which is going to execute the whole command is the load, because that is more like a trigger which let the Spark know that okay, now it needs to evaluate the whole command which has been previously been built in the DAC. And DAC is more like a direct acyclic graph. What it is, don't worry about it. There's a full discussion about it. But at the end, that's the load command that you need to use, and you just need to pass the options, which are more like what options you want to pass during the load process. And you can see in first schema, we are not letting Spark to interpret the schema. We are providing the header in the first row, and we are providing the separator, which is the comma. Very simple. So that table has been loaded. Now let's come and load it the second one. By the way, if you forgot that whether you have executed that command or not, there's a timestamp in here. You can see when the command has been executed. It's going to actually put the time spent. So you can see I've just executed this command like couple of seconds before. So I'm good with this command. However, the next command has the old timestamp. There was the timestamp which when I was building this notebook, I put it when I ran that time. That's the last timestamp it was referring to. I'm going to run it again. So because the data is small, so it was pretty quick. Let me run the next one. I'm loading the employee department history. I'm going to load the department, and then I'm going to load the shift. So these are the 5 table. I have loaded it, and trust me, in the real environment, once you do the ETL, you have to automate all these things. But eventually, the ETL or data pipelines are going to work on the same principle. You need to automate the whole thing. You need to put the routine that can read the file, and like I mentioned in my previous video, how we can look at the file and we can extract some metadata, and you have the full capabilities available from the programming side, so you can build some really powerful I would say ETL flow or data flow based on the requirements given by the business. And at the end, you can automate the whole notebook. You can literally call this notebook, if you are using Azure, you can call it into the Azure Data Factory as a step, and then once the notebook has been executed successfully, then the subsequent steps can be executed, even further process that data. So you think about how we are entering from the not small data, but more like the structured data. We are moving away with the unlimited option, where we can handle the structured data, we can handle the unstructured data, and our data pipeline building capabilities are even more. Like we can build any kind of ETL workload in conjunction of using Azure Data Factory or the Databricks. And if you are using AWS, then Glue come into the picture, which has the similar technology underneath, and you can literally configure the Spark in your AMR cluster in AWS. So that's an other set of technology which is available to us, right? So there's a lot of interesting thing we have that we can use from the technologies perspective. Tell you the truth, we don't have any limit, I believe now, from the technology side, especially with the cloud and all these modern technology. They equip us completely to handle any kind of data load or any kind of complexity. We can easily deal it. The issue is with the process, the issue is with the ambiguity, the issue is uncertainty, the gaps that we normally find in the logic, and we are not sure what we're gonna do, and that's where the whole challenge start to impact the whole data flow. Bigger discussions coming back to our notebook. So we have already loaded. Very first thing, always remember, whenever you load the data, always check the schema. And obviously, you are only going to do it while you are developing. Once you release the notebook into production, you don't need to, because it will run automatically. It will based on the schema that you have defined. And what's the advantage? If something is not in the right data type, you can convert it, right? But once you convert it, you don't need to execute this command in production, because that's not going to give any advantage, because that automation is going to, that cell is going to be automated. It's not going to produce any output for you, right? And if we have expectation that schema is going to be changed in the production, we have different patterns that we can handle it. So it's more like from the dev environment perspective, that I've checked the schema, and what I realized, my modified date is coming in string value. However, a modified date theoretically come as a date type. So that's fine. I know that there's a challenge. Spark is not loading it into the right data type. So what we are going to do, we are going to change the data type by ourselves. And the command is very simple. With column, we can define the column, and then what we can do, we have the expression, and that's where all these libraries comes. If you remember, we discussed this expression. Expression is more like let you execute an expression which has been defined according to the syntax of the library. So, for example, I have a cast function in the Spark SQL, and I want to apply that function on one of my column. So I'm going to put that function within the expression. That's the only difference. Normally in the SQL, what we do, if I need to cast anything, I just put that command straight in there, and that command will execute. The difference in using in the PySpark, because if you can see, the default language of the notebook is Python. In Python or in even Scala, the only difference, you need to put the whole thing in the expression function, because that will let the Spark engine know that okay, it needs to execute the whatever inside is as an expression, and whatever the outcome will be, that will return to the data frame. So you can see we are defining a new column. So that column, and obviously we are going to override that column with the existing one. So that column, which is with the string data type, is going to be overwritten with our new column, which is going to be date data type, right? And then we are putting our result back onto our data frame. Now let me run it. So it's pretty quick, like you can see 0.11 second, and let me now run to see whether the column data type has been changed, and you can see the modified date has been changed from string to date type. So that's how we can infer the schema, and we can change the data types if we have to. Obviously in the real life, we face this kind of issue a lot. And then obviously that's where the complexity comes in. Right now you can see the conversion is simple, but in the practical environment we deal with a lot of scenarios, and things happen all the time. You come across with uncertain situation which you have no idea before that how you're gonna tackle them, but once they occur, that will help you to improve your ETL. And that's why ETL is a continuous evolving process, because more unforeseen scenario occurs in front of you, that will help you to improve the robustness of your ETL, right? And obviously there are some use cases that you have to address as part of your development. Those should be passed before you release that data pipeline into the production environment. Now moving on. So we are good. We have changed the data type. Our schema looks sweet in the person data frame. Let me just get the first 100 record just to sense check the data sitting in our data frame. And I can see, yeah, my modified date is coming as a date type, and then I have row GUID, we have demographics, some column, and you can see these are the familiar types, right, that we have discussed multiple times in the past. And then obviously I'm going to do the same thing with employees. Yeah, I have the employee data available. It looks like it's a white table and it's not fitting into the width of the screen. So you can see some of the columns shifted to the next. So don't worry about the output format, because we are not going to use in this way. And then we have print schema to check the employed table schema. And I'm not changing anything, even though I know that modified date is again string in here. It was just like, if you want, you can do it. It's more like, once you learn one concept, you just need to apply it whenever you face that condition. And that's how you get the skills or expertise into any domain. Just on the safe side, I'm checking my departments to sense check the data into the department table. Looks good. Let me run the department schema as well. Modified date is again string, should be all right. By the way, I'm actually now counting my total records in the table as well. So in the department employee department history, the total number of records are 296. Let me print the schema. Schema looks good, and let me, by the way, you can see I'm again changing the employee history date in here. It's just more like a random thing. I didn't realize I have put it in my notebook. Nothing fancy in here, trust me. Let me see the shift data. We only have 3 records, and shift table is quite small because we only have 3 shifts. And if you don't understand the schema, I would strongly encourage again, go back and check the video on where on the data modeling of the human resource. So let's check the, oh, by the way, shift has 2 columns, start time and end time. And actually, I was thinking that we can literally use these 2 times to do some really good stuff. So let's change the data types on these 2 columns. So I'm going to do, let me just copy that. All right. So I'm just going to change first. Let me change the F. Or fit column, and I'm first going to change the start time. And I'm just changing it as a, I would strongly encourage to visit the documentation again and again. Databricks has put some really good documentation, and even on the Spark website, you're gonna find really useful documents on these function, and you can get the help and even the practical example on all the function if you want to use them. So for example, if you want to use the cast, I would encourage to go back and look at the cast function. In one of the video, we have already seen how we can get the help quickly and how we can see the practical example. Okay. So by the way, in that time, if I want to capture the time, we can use the timestamp. These are the 2 types available. So let me run it, see, yeah, it's all good. Let me just see the schema. And you can see now timestamp is coming as a timestamp column instead of, the string column. What I'm going to do, let me just show you the table data just to check. So now you can see we are getting the date as well. So we are so there's a problem, there's a logical problem, like it shouldn't put the 2022-07-10, because what it is doing, it is because the date is not available. So what it is doing, it is just putting the current date and embedding it with the time, which is not the right thing. So I think I have to change I have to revert the change. And what I'm going to do, I'm just going to do the string. Let's keep the string at this stage, and later on we'll see how we can handle it in the SQL level. And that's the beauty. I know that at the Python level, it's giving me trouble to change it. So don't worry, we can handle it. We still have another place where we can handle it, and I'm going to show you where we can handle it easily. So you can see the value has been changed again to string, and just show you the correction of the data. You can see. Did I execute? Yeah, I did execute. And it has been changed. Okay, still, because it has already stored the value. So it might be I need to reload the file in here, because the value has been stored in the column. So it is not, even I convert the data type, it is not changing the value, which is fine. What I can do, I can come in and I can, yeah, the cell, I can reload the data from my files, because our original data is securely stored on our operating system. So now if I come back and if I can see now, I do believe it's going to be good. Yeah, we can see the values has been reverted. Now the shift table has been loaded. All our data frames are loaded and they are ready. And we are going to run the SQL statement on them. Excuse me. So first we need to convert them into view, which is a common way to run this SQL statement against the data frame, that we convert them into a temporary view and then we use them. So what I'm going to do, so if we go back into our notebook, you can see I have actually called each data frame with the corresponding create or replace temporary view, and then I provided the view name. So it will convert it into a temp view. So I have 5 tables at 5 data frames. So I'm going to create these 5 views for each respectively. So let's run the command, and it has converted all of them into the view. And let's check all the views just for the sense checks. So the person has 19,972 records, which is correct. And then employee has 290 out of 19,972 record. We only have 290 employees record. If you remember the data model, you can easily now match all these back to the data model, which I have already discussed in the previous video. We have 16 departments and we have 3 shifts. So we have checked all the counts, which is a normal practice. Once you load the data, just make sure you check the count so you are aware that, okay, all the data has been loaded correctly. Normally, as a tip in the production environment, what we do, because we cannot see it the output of the notebook, because we are not running interactively, and maybe the notebook is running 12 o'clock or 1 o'clock in the night. So how are you going to actually wake up and check the outcome? So we normally store all these value as a log into either a file or in a table, and later on we check the file and find out is there any error or if there are any mismatch in the count. So that's how you can troubleshoot any ETL issue or any gaps in the data. Just on a tip perspective. Now we're going to actually look at the first 100 records. So now you can see the same outcome, but now it is coming in the tabular format. So you can see we have the same table which we have previously used in the SQL server. Now that the same table with the same columns are available in the Spark SQL. Let's see the employee record. We have, you can see, sorry, it is in here. We have business entity ID. And by the way, if you can check, business entity ID is common between these 2 tables. So remember, we are discussing join. So we're going to use that column to link these 2 tables, right? If we want to link person table with the employee table, we're going to use that common key between these 2 tables to use for our join. So you can see we have employee related information. We have login ID, organization node, organization level, job title, birthday, marital status, gender, hire date. There are a bunch of columns which are related to the employment. By the way, that table is really going to help us to generate some interesting analytics. The next table is a department, and you can see, I think previously I have run it in a row. So you can see we have department, we have name, we have the group name, and we have the modified date. And group name is more like, every department has a sub department. So you can see that's how we normally manage multiple level into a single table. There are multiple techniques we can use, but that's one of them. You can see one group name with the name is uniquely identify the full department, because maybe research and development has engineering sub department, research and development has the tool design sub department. So you can see there's a parent child relationship here. Okay, and then obviously, if you remember, we discussed the employee department history concept, that maybe one employee is working into multiple departments over his stay in an organization. So we cannot, link the department directly to the employee, because that's going to violate the relationship between these two table. We need to introduce a bridge table that can contain the history of that employee if he's working into multiple departments over his stay in an organization, which is a very common practice in the enterprises. People join in one department, and then after some time they move towards the other department and a different title, and then that's how we actually keep their record. And last but not the least is our shift table, which is going to show you the total. We only have 3 records. Let me just change it. Take out the limit clause. Okay, now coming back to the main topic of the video, how we're gonna write the join. So now we reach to the point. Everything we have prepared is now up and running. So nice and sweet. We can see all our data is loaded into our view. They are ready to produce the outcome that we want to. So let's see. We are first going to join the employee table with person, and like I mentioned in the above cell, that we have 296 records. If we can just scroll a little bit up, we can see we have 296 records and we have 19,972. And if you remember the inner join, once we join 2 tables through inner join, we're going to get the common record. And as a tip, always remember, whichever side has the less record, that side is going to come into the result side. It might be possible the results are even less than the alert side, because it might be some records are sitting on one side which are not present on the other side, so they're not going to appear on the inner join, right? But as a tip, we always look at the minimum side, because minimum side is always going to appear into the final result. So let's see. The syntax, like I mentioned, is going to be same. We are going to use inner join clause, and then you can see we are using alias to reflect the table name, because we don't want to write the table name again and again. And you can see I'm writing the column name. So the syntax is exactly the same, because that's where the SQL standard clauses comes into the picture. SQL language has its own NSI standard, which every language needs to follow who are providing the SQL capabilities. But obviously there are additional functionality that you can introduce on top of these standards. So these standards vary from language to language. Obviously, you're gonna find something in SQL Server which might not be available in the Spark SQL. You're gonna find something in Oracle which might not be available in the SQL Server. So it's really depend upon the database software and what engineering they have actually implemented and what library they have built as part of their database engine API that is providing us the function and libraries, right? But always remember, if you are facing any lack of capabilities in any language, there is always the opportunity to build it by yourself. And how you're gonna do it, we'll see it in the future video. So our records, our query is fine. We are linking. So let me read this way. We are linking person table with employee table through inner join based upon business entity ID column, which is the common column on both sides. Syntax we have already seen in the previous video and in this video as well briefly. Let's run it and you're gonna see. There we go. If I actually, you can see showing all 290 rows. So now that 290 rows are coming from the left side, which is obviously employee side. So now we know that all the employee records, they are available in the person record. So that means more like, you know, all the employees have the corresponding personal record, which is good. So you can see I've just, you know, just for the sake of understanding, I bring some of the columns on both sides. You can see I have business entity ID, which is coming from person. We have person type, we have title, first name, middle name, last name. Job title is coming from employee, birth date is coming from employee, and current flag is coming from employee. Now, so if we want to, so for example, if I want to see if there is any missing record from the person side. So the concept is similar, like I need to write a left join because person is left on my join, person is on the left side of my join. And what I'm going to do, I'm just going to change the inner join to left join. I can write left outer join, but left join is more like a short version. And then what it will do, it will bring all those records which has a common key on both sides. On top of that, it's going to bring all those records which are sitting on the left table, which don't have the corresponding right side. So let's run it and then we'll see how it goes. So you can see we are getting 1000 record. I'm just going to do a small hack which I didn't discuss, but just to show you the total record which we are getting, and then I will explain it in the corresponding video. I'm just trying to write the subquery just to show you how many records we are getting. Just ignore the subquery if you don't understand. Leave it. I'll explain it later. Now you can see we have 19,972 records, which are coming as an outcome of this query. Don't worry if you don't understand the subquery at this stage. I'm going to actually explain it later, but just want to show you how many records this query is returning back to us, and that's the exact number we are getting on the left side of our join. So that is 19,972 records which are coming from the percent table. So that's the left join. And now if we go back to the next cell, and by the way, by default, if you try to run a query and you don't specify the limit, the default limit is 1000 records which have been returned from the Spark SQL. If you want to extend, I think in the free edition it won't return more than 1000 record. We can check with the professional edition that what's the limit of returning of the record returns. Now the next one is right join, where we are going to see if there is any record which are coming, which are sitting on the right hand side, and right hand side is the employee side. So any record which is which is in the employee side, but don't have any corresponding instance in the person side. So if we have any record through the right join, we can extract that record. So let's run it and see if we have any record which are popping up on the screen. Now we have all 290 records. So that means all employee records are coming as part of the inner join. So you can see the outcome of the inner join and right join are same. So I can show you in here. So that's the outcome of the inner join, and that's the outcome of the right join. So that means the employee table is fully contained within the person table. And then obviously last but not the least, if we want to bring everything from both sides, so we are going to use the full outer join. So you're gonna see we have, so we have 19,975 record. I'm not going to actually hack this script now, but you can see it is just returning the 1000 record. If I actually count the total number of records of the full outer join, it is going to be equal to the left join, because on the left side we have some records which are not coming as part of the inner join, but we don't have any record which is on the right side and not appearing on the right join outcome. So you can see the that's why we are getting as a part of the full outer join, we are getting 19,000 record in total. And just for the sake of clarity, let's run and let's do the So you can see 900, 972, which is equal to left join, because we don't have any record on the right hand side, which is not present in the percent table or in the left hand side. Now, before I finish the video, I'm just going to now again doing the last join, last but not the least, which is obviously what, if you remember, we discussed the antenna join, where we are going to bring both sides which are not available in the interaction or sorry, in the intersect of both table. So in other words, we are only getting those records which are either present on the left side or the right side. A common question which come in the inter engineering interviews. So let's see in here. So let me just take out the subquery clause. I'm not going to discuss subquery in this video. So let me write down where p dot entity, that's business. I hate it when it does these things. So what I'm going to do, I'm just going to where anything in the full outer join which is sitting on the left hand side and is null, that means it's going to bring all those records which don't have the corresponding instance on the right hand side. And similar way we're going to actually, or we're going to bring those as well where we have the instance which are sitting on the right hand side and they don't have the entry on the left hand side table. And now you will see we have all these records which are coming from the person side, like I mentioned, because person has those records which are not present in the employee side. So you can see all the corresponding records are coming as null. And if you don't remember this concept, please watch the anti-inner join video which I've already recorded for SQL Server, because I've actually explained in brief detail how the anti-inner join works. So guys, you can see we are getting still more than 1,000 records. And just to sake of clarity, let me show you the total count again. How it's going to be different than the previous count, because obviously we are only getting those instances which are present on one side. So and let me run it. You can see we have 19,682 records. So obviously we have 290 records common, and then if we take out those two common records, so let me just do the calculation in front of you. So 19,972 minus 19,682. So we have 290. So that's also the 290 records are common on both sides, which has been excluded into the anti-inner join, and we are only getting 19,682 records. So hopefully this video makes sense. You are able to understand how the joins work in the Spark SQL. If you like, please like or put any comments if you have any question. Thanks for watching, and I'm gonna see you in the next video where we are going to write these subqueries in the Spark SQL. Thank you.